We're still in lesson 1. This is what's on your quiz on Friday. So what I taught on Friday, using standard form and using the negative b over 2a to find the x of the vertex and the axis of symmetry, that's on the quiz. And then what I'm teaching today, transforming our equation into vertex form using completing the square. So again, vertex form, we saw this on Friday, where this a that's in front is the same a that's in standard form a, but again, this h and this k give us the vertex. Remember to find intercepts, to find the y-intercept, I would set x equal to 0. To find the y-intercept, I would set y equal to 0. So when we're doing this, we're going to first transform it into vertex form. Then we're going to find the vertex. We're going to find the axis of symmetry, the x-intercepts, the y-intercepts, and I guess the axis of symmetry if I didn't say that. But let's go through these. Notice part of our equation is a negative sign. So that's why what went in here, because this was already here, and what went in there was a positive 3. Now, if it were a plus sign, then what went in there was negative. Does that make sense? So it's back. So here's my first example. Now, I could go ahead and find my vertex by doing the negative b over 2a. However, part of the answer on the quiz will say, use completing the square and transform your equation into vertex form. And what we're going to do is, when we did this before, remember our equations look like this. They were just quadratics. It was x squared minus 6x minus 3 equals 0. So if you recall back the other method, we would move the 3. Remember, you move the constant to the other side. That made a blank space. And then you take the b term, divide it by 2, square it. So negative 3 squared. That would have been what you added to both sides. You guys remembering all this? This is the old way, and I'm going to show you the new way in a minute. Instead of putting it here, I'm going to put it in as what I got. So negative 3 squared. So then this factors into x minus 3 squared equals 12. And then you would have solved it from there by using the square root method. So this was the old way. I'm going to show you the new way. Everybody with me? So here's what we're going to do instead. Because we have a y now to consider. Before we didn't have the y. Now we do. So let's go ahead and y equals x squared minus 6x minus 3. Same equation. Here's what we're doing different. So now instead of moving the constant to the other side, I'm going to take that constant and I'm going to just shift it over. And I'm going to make a blank space here. I'm still going to take the b term, divide it by 2, and square it. So this becomes negative 3 squared. So that's what I'm going to put in here. Now, remember before we would get 9, right? And we would add that to both sides. But now because I didn't move this 3 to the other side, instead of adding it, I'm going to subtract it. Okay? So whenever your equation starts out with without an a term or your a term is 1, what we're going to do is once we divide the b term by 2 and square it, instead of adding that, we're going to subtract it to the constant. Now I need to factor this. So remember, the reason why I put this in here like this is you're just going to turn it into x minus 3 squared. Whatever you got when you divided the b term by 2 is the number that goes in there with that x. Then I'm going to add these guys, and this becomes negative 12. And my equation's in vertex form. This is my h, this is my k. So my vertex is the order pair 3, negative 12. Remember, the H is opposite of what you would think. The axis of symmetry is the H, and it's an equation. So it's x equals 3. Yes?
Why would it be negative 3?
Okay, so if you recall back on this slide of what you would think. So you're just pulling out the number itself if it's a minus sign.
Okay.
Good? All right.
The axis symmetry is 3?
I'm sorry?
The axis symmetry is just 3?
X equals 3. Again, remember, it's an equation. It's a line. It's that vertical line through the vertex. And it's the x of the vertex. And in this case, it's our h. Next thing I need to find is the y-intercept. On Friday, anybody remember what the y-intercept was from the standard form?
C.
The C, good. So let's go back to the beginning. And here's my C. So to get the y-intercept, I'm always going to go back to the original, and that's my y-intercept right there. So my y-intercept is going to be the ordered pair, 0, negative 3. Now, technically, I could have plugged in x equals 0 into my vertex form and solved for y that way. Does that make sense? Because again, to find intercepts, you plug in zeros. Okay, next I have to find the x-intercept, or intercepts, it depends. Because remember, when we graph these parabolas, it can either hit it 2 times, meaning I have 2 x-intercepts. It could be sitting on the y-axis, and that would have no x-intercepts. This would be no x-intercepts. This has 2. And then it can also have 1, for example, if it's sitting on the x-axis. So we won't know until we actually, solve this. So there's 2 ways to find the x-intercepts. Okay? Again, remember you're setting y equal to 0. So you can either take the original, and if it could be factored, you can find the x-intercepts that way. Or take your vertex form. Y is equal to 0, so x minus 3 squared. And this is where we do the square root method. Add 12. 12 is equal to x minus 3 squared. Square root both sides. This becomes plus and minus square root of 12. I need to simplify the square root of 12. 4 and 3. So this becomes plus and minus 2 square root 3. I still need to solve for x. So I'll add the 3. So x is equal to 3 plus or minus 2 square root 3. Now, if you think about this, this plus minus means I have an x-intercept at 3 plus 2 radical 3, comma 0, and 3 minus 2 radical 3, comma 0. These are my 2 x-intercepts. Now, if on the quiz, if you just want to write it like this, that's fine. But just realize if you're graphing, it's actually got 2 x-intercepts. You're finding the vertex, the axis of symmetry, the y-intercept. You're also finding the vertex form, and then you're finding the x-intercepts. Either one of these. Let's try another example. Yes?
To find that x-intercept, you're just square rooting what?
You could just use the square root method on your vertex form. Because remember, this was my vertex form. But it was y equals, and I set y equal to 0. So remember, to find intercepts, you plug in zeros. To find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. But if you have standard form, remember the y-intercept is just your c. All right, let's try another one. So here we go. We're going to do the new method where we're not going to move the 7 over to the y. We're going to move it over and leave a blank space. So it'll become y equals x squared minus 4x, shift it over. I now take the b term, divide it by 2, and square it. So that's what's going to fill into my blank space is the negative 2 squared. Now remember, this negative 2 really becomes 4, but because I didn't move it to the other side, I'm not adding 4, I'm minusing 4. Now I factor the trinomial, and again, as long as you remember what you got when you divided the b term by 2, that's what goes in the binomial. And now you do negative 7 minus 4. And you're in vertex form. Yes. The quiz, you're going to put it in vertex form. So on the line on the quiz where it says, then next line it'll say find the vertex. And we'll fill that in with the h and the k. So positive 2, negative 11. The next thing it'll ask for is axis of symmetry. And again, it's the x of the vertex. So x equals 2. Next thing it'll ask for is y-intercept. And that you can go back to the original. It's right here. And it's written as a coordinate. So you're going to write it as 0, negative 7. And now to find the x-intercepts, I could either try to factor the original, which I can't. So instead, I'm going to use my vertex form, and I'm going to set y equal to 0. So 0 equals x minus 2 squared minus 11. Add the 11. 11 equals x minus 2 squared. I now apply the square root method. Plus and minus square root of 11 equals x minus 2. Move the 2. So my x-intercept is at 2 plus or minus square root of 11. So again, written as an ordered pair. You can either write it with the shorthand here or write it as 2 plus square root of 11 and then 2 minus square root of 11. And that's your x-intercept. Yeah. So let's say instead we ended up with like 2 plus or minus the square root of 16. I would expect you to turn this actually into a number and do 2 plus like this and get 2 plus 4, 2 minus 4, and get 6 and negative 2. So the two x-intercepts, if this were the scenario, would be 6, 0 and negative 2, 0. And we're going to see this coming up in a minute. So if the radical, if it's a perfect square, you actually have to do the problem. However, here, I'm okay with you leaving it with the plus minus if there's a radical. So for this one, let's go ahead and shift over the negative 4. Take the b term, divide it by 2, and square it. I get 25 over 4. So in here, I'm going to fill in the negative 5/2 squared. But over here, remember backwards of what you think. So instead of adding it, I'm subtracting 25 over 4. I now need to factor this and then add these two together. They're the same signs. So negative 4 minus 25 over 4, common denominator. I'm going to make this negative 16 over 4. So I get negative 41 over 4. And then this thing factors into x minus 5/2 squared. Yes?
The negative 5 over 2 squared, what are we doing to that? Like, is that 5x minus 5?
So really technically what this is x squared minus 5x plus 25 over 4.
Okay.
And then you're factoring that. So that's why instead of having to try to figure out what are the factors of 25 over 4 that give me -5, if I just leave it like this, then I don't have to think about it. It's just the b term divided by 2.
Okay.
All right, so now it's in vertex form. So now my vertex is the ordered pair 5/2 and -41 over 4. My axis of symmetry is x equals 5/2. My y-intercept, if I go back to the beginning, my c was -4. It's right here. So again, as an ordered pair, it's 0, -4. Now to find my x-intercepts, I'm going to use my vertex form, which is right here, and use the square root method. So y equals x minus 5/2 squared. I'm going to plug in a 0 for y. This is the x-intercept work. I'm going to move the 41 over 4 to the other side. (41 over 4 equals x minus 5/2 squared). Square root both sides. This becomes plus and minus. I could square root the 4. It becomes a 2. 41 is not a perfect square, and I can't break it down, so I leave it under the radical. And now I'll add the 5/2. So 5 over 2 plus or minus square root 41 over 2 equals x. Now if you want to write it with just 1, 2 in the bottom, you can. You could just do this, comma 0. If you want to split it apart, you can also do that. Either way. All right, now we're going to have an a term. That's not a 1. Pretty good on this one? Now, normally when we did completing the square, remember we divided everything by 2. But if I divide all 4 terms by 2, I'm going to get a y over 2, and I don't want that. So I'm going to do this part a little differently also. Instead, I'm going to factor out a GCF of 2 out of the first 2 terms. So this will become y equals 2 x squared minus 3 over 2x, leave the blank space, and shift the 1 out. I now take the b term, divide it by 2, and square it. So again, divide by 2 is the same thing as multiplying by 1/2. So this becomes -3/4 squared, which gives me 9/16. Everybody with me? Now, so that's what I'm going to fill in here is this right here. Now, we still have to, notice I didn't factor this 2 out of the 1. So now what I need to do is compensate for that 2. So this 9/16, I'm now going to multiply before I put it on the other side. So I'm going to multiply what I'm about to subtract from the other side, because remember it's opposite. So this becomes an 8. So now instead I'm going to subtract 9 over 8. Because really what I added here was positive 9 over 8. So now this could I turn into 9 over 9. Oh, no, not 9 over 9. 8 over 8 minus 9 over 8. So this actually simplifies to 1/8 negative. So now I have this. This thing factored is just x minus 3/4 squared minus 1/8. So this is that. It's now in vertex form. So my H is here, my K is there. So my vertex is located at 3/4 and -1/8.
So you don't distribute to.
Nope. Remember, the 2 just makes it go up faster or slower. So it's not going to affect where the vertex is, but it does affect the other points on the parabola. My axis of symmetry is x equals 3/4. For my y-intercept, I could go back to the original, and my y-intercept is at 1. So 0, 1. Now, this one actually could have been factored from the beginning to get the x-intercepts. I'm actually going to show you both ways. So if you want to try to factor the original, which was 2x squared minus 3x plus 1, this was the original problem. Again, to find an x-intercept, I'm setting y equal to 0. So I can actually factor my standard form into 2x minus 1 times x minus 1. Set each factor equal to 0. And solve for x. So x equals 1/2 and x equals 1. So my 2 x-intercepts occur at 1/2, 0 and 1, 0. Now, let's say you guys don't like factoring. Instead, you wanted to just use your vertex form. Again, your vertex form was this. Again, set y equal to 0. I'm going to move the 1/8 first. So I'm trying to solve for x. I'm not going to distribute. You could square, you could FOIL it and make it a lot harder than it needs to be, but here's how I'm going to do this one. I'm going to add 1/8. Then I'm going to divide by 2. One-eighth divided by 2 is the same thing as 1/8 times 1/2. So this becomes 1/16. Oh, the 2 is gone. So now I have x minus 3/4 squared. And now I apply the square root method. Plus and minus 1/4 equals x minus 3/4. See why factoring it's a little bit easier? Now, once I move the 3/4 over, notice my radical disappeared. So now my answers are going to be 3/4 plus minus 1/4. So I actually have to do the problem. So 3/4 plus 1/4 and 3/4 minus 1/4. This gives me 4/4, which gives me 1 whole. This gives me 2/4, which is 1/2. Same order pairs that I got, 1, 0, 1/2, 0, as when I factored it. So you can do it either way. One more example. Last one. So again, notice the number in front of x squared is not a positive 1. So again, I'm going to factor out a GCF of -1 out of just the first 2 terms. So it's -1, and then x squared minus 3x, leave a blank space, shift the -4 over. I now take the b term, divide it by 2, and square it. Actually, just square it here, and this becomes 9/4. So if I put in here -3/2 squared. Now remember, we have to consider the -1. So now what I'm really doing to both sides, if I would have moved it over, was subtract 9/4. So again, it's opposite. So what I'm going to do here is add 9/4. Normally it's always subtract, but when you have a number in front that you factored out, then you, again, multiply it and do opposite. So now y equals x minus 3/2 squared. I'm going to go ahead and find a common denominator here. It's going to be 4. And now I get minus 7/4. And I have the negative out here because that indicates it's a reflection. So my vertex is at 3/2 and negative 7/4. My axis of symmetry is at x equals 3/2. My y-intercept, if I go back to the beginning, was -4, so it's 0, -4. Now, watch what happens when I go to find my x-intercepts. Again, I'm going to take my vertex form. I'm going to add the 7/4. And this is actually a 0 because I'm finding a y-intercept or x-intercept. So I set y equal to 0. So 7/4 is equal to negative and then x minus 3/2 squared. I want to get rid of the -1. So now negative 7/4 equals x minus 3/2 squared. When I apply the square root method, notice I'm getting an imaginary number. So this will have no x-intercepts. If you wanted to go ahead and solve it, it's plus and minus I, radical 7/2. Add the 3/2. We're not graphing imaginary numbers. So 3/2 plus or minus I, radical 7/2. This would be where the x-intercepts, or this would be your imaginary. So again, when this occurs, when I get an I in my answer, you're going to write that there are no x-intercepts. So that was the last example. Again, we're going to practice it tomorrow. There is a 10-question classwork that we're going to do in class tomorrow, and I will be posting a solution file probably tomorrow or the next day. Let's go back. Because I factored out a -1 GCF, which made this -3 become, or this +3 become negative. And then I take this B term and I divided it by 2. And that's why it's negative. Okay, and again, here is the x-intercepts. Again, I used the square root method. I plugged in y equals 0 and solved for x. Quiz, you're going to put no x-intercepts. All right, so again, there is a worksheet. I did publish it last period. It has 10 questions. However, we will be working on that in class tomorrow. And this is what's on your quiz. In addition to what we learned on Friday, using the vertex formula, the -b/2a.